So we're going to be, this whole chapter 4 is about quadratics again. Hooray! But this time we're doing it a little bit different. Last chapter was all about quadratics in vertex form. This whole chapter is about quadratics in standard form. Okay? So today, the first thing we're going to do with these things in standard form is we're going to learn how to find their x-intercepts, which is also known as the root. Let me figure something out real quick here. Okay. Now, there are two different ways that you guys may see a quadratic. There's this one, which is what we just finished talking about in chapter 3. This is a good strategy. I like this one because it just connects nicely with all your Algebra 1 skills that you already know, like solving for x, graphing. It's pretty simple. However, the thing is that standard form is actually how they usually look. Standard usually means kind of like regular. So usually they look like this. They're both quadratic, because quadratics are equations where the x variable is being squared, and they both have that in this case. Vertex is more convenient. It's an easier place to start. Standard is what you kind of also want to know, though, because it's actually more common. Okay? So now let's review for a quick second here. How do you find the y-intercept?
Do you have to write that down?
Sure.
You would replace the x and
That's right.
Or can we just put plug 0 in for x?
Yeah, it's the same thing, but
Okay.
Let me find the x-intercept. That's right. That's right. Now, on a graph, I'm going to draw a picture here. I'm going to label these A, B, and C. Which one of these is an x-intercept? A and C, right? B is the y-intercept, because B is where it's touching the y-axis. Oops, an extra mark there. Let me undo that. Just the y-axis, x-axis. So B is where the parabola is touching the y-axis. A and C is where it's touching the x-axis. So these are the x-intercepts. And that one there is the y-intercept. Okay? So that's just some review stuff that we talked about. Today, what we're doing, once again, now that we've kind of reviewed all that stuff, is we're learning how to find the, oh my goodness.
whoa, what did you do?
I don't know, my computer wigged out on me. Hold on. That was weird.
You didn't even touch it hard.
I don't know what happened. All right, anyway. Today we'll be finding the x-intercept. So we're going to find where it's touching the x-axis when it's in standard form. Now you might think, okay, big deal. We're going to do the same thing. Just plug 0 in for y and solve for x. The problem is you can't really just solve for x anymore. It doesn't quite work like that. I'll show you in a minute why that is. But for now, it gets a little bit trickier. You guys are all going to go, oh yeah, when I show you how to do it though. Okay. But that's what we're doing, is we're learning how to find that. Now, why do we care about finding the x-intercept? Well, one reason is because, yeah, I mean, they're kind of like nice anchor points. Like if you want to graph one, that's part of the process, is finding some important points, and root or the x-intercept is a good place to begin doing that. Another reason why is because when you do word problems, we did this in our last unit. Remember whenever it was on the x-axis, that represented when the ball landed on the ground? So a lot of times roots mean something in the context of like a word problem. So that's why it's important to know how to find those. Okay. So that's our goal, finding these points when we are in standard form, because it's helpful for graphing and also for word problems. So now we're on to the big question then. So how do we find the roots? Oh, by the way, I'm saying roots. Do you guys remember what that means? It's the good job. It means x-intercept. So I'll just put that in parentheses here. How do we find the roots when a quadratic is in standard form? That's the crowning question of the day. I want to make sure you know the answer to this. Now, when it was in vertex form, it was pretty simple. We just plugged in 0 for y and we solved for x, just doing some basic algebra stuff. That won't work here. I'll show you why. So let's suppose that I have this. 3x squared minus 4x plus 1 equals y. So let's just say we want to go through the process, right? So step 1, plug 0 in for y, right? That's what we would usually do. Here's our problem. You can't get x by itself. The reason you can't get x by itself is because I have two x's here, don't I?
Yeah.
And we can't combine them. You know why?
Is it because x?
Yeah, one's a square, one's not. They're not like terms. So there's no way I can get them to be together as 1x. And if I can't get them to be together as 1x, then I can't get x by itself. Now, actually, you guys do have all the tools necessary to be able to get these x's together using a strategy from last chapter. But I don't want to harass you with that right now. Yeah? Yep. So, but here's the answer. You guys ready? How do we do it? Step 2. You're going to love this. It's your favorite. Everybody's going to say, oh yeah, I remember that. Oh my freaking gosh. If my computer will let me write, well, I'll have a great aha moment. X equals, that's your, remember your roots are x. Yeah, this is our x values, our roots, right? Here's how you do it. There he is.
Out of here, dude. Nobody wants to see this.
That's the thing that does it. Everybody remembers that formula, but I don't think very many people remember what that formula is for. What it's for is for what?
For like
For the murder of innocent people.
Finding the root.
Hey,
I've just been talking about it for like 15 minutes. It's for finding the roots. So people all remember the formula, but people never remember what it's for. It's for finding the roots. Yeah, it's called the quadratic formula. So what this guy does is it's like what's the point of this big ugly beast? It's all about finding where it touches the x-axis. That's what that thing does. Okay? So I don't want you guys to forget that. I want you guys to walk out of here knowing Mr. Bailey's class that Now you guys remember from your 8th grade and Algebra 1 that, oh, that's the quadratic form. You guys know that. But now I want you to walk out of here saying, now I know what it's for. It's for finding the roots, okay? Because that's what it's for. Okay? So, that's our task for the day. So let's get down to business. We're going to start off with some simple examples. They're simple because you end up with really nice, clean answers. And then we're going to do some examples where you get messy answers. The big terror with this thing is your order of operations. But it's the same every time. So here we go. Example 1. Find the roots. That's our direction. Find the roots. Ew. That's a big number. Oh well. Oh, I put 0. Shame on me. We're going to put a Y there for me. Okay. So, first question. I am going to use my cards, but if you say I don't know, that's okay. I will judge you and think less of you, but it won't affect your grade. Anybody with a sense of humor will know I was making a joke. All right, here we go. So I'm going to ask Micah. This is asking me to find the roots, right? And that's just fancy words for what? The x-intercepts. And then Kenneth, as I look at this equation, I notice that what form is this in? I'll give you multiple choice. Is this vertex form or standard form? It's standard form. Okay. And then Joanne, we just learned today that if I want to find the roots of a quadratic in standard form, what do I do? Great. I'm going to stop you there. Just like when we're doing vertex form, the first thing you do is you plug in 0 for y. But after that, what do we do, Leslie? I bet you do. You just don't know how to say it. But the answer is you're going to use the quadratic formula. That big nasty b over 2a thing I just gave you. Ready? So here we go. The number in front of the x squared is the a. Let's circle that. The number in front of the x is the b. Now I like to circle them because I get a lot of students that put the x's in there and you don't. It's just the number in front of the x's, okay? And then the number without an x is the c. Now notice I'm including the signs because those are part of those. So a is 5, b is 6, c is negative 144. Okay? So, step 1, ready?
How come we don't include the x squared?
It's just not how the formula works.
Oh, okay.
All right.
Yeah.
So step 1 is to identify A, B, and C and plug them in. All right, so I want you guys to write the following thing with me. Ready? There we go again. All right, ready? X equals, and I'm going to put negative blank plus or minus the square root of blank squared minus 4 times blank over 2 blank. Oops, did it again. So I'll pause, make sure you guys have all your blanks ready to go there. Guys that you copied down earlier today, the quadratic formula, what letter goes here?
6. Wait, what's your name?
What letter?
B.
The B goes here. So what number am I going to put there? Because 6 is my B. What letter goes here? B again. So what number is B?
6.
What letter goes here? A. So I'm going to put what number? Okay, I'm gonna squish it in there. Negative 144 is my C value, right? That's the C. What number goes here? A? So that's number, okay. So that's the first thing you gotta do is plug them in the right spot. Okay? Okay. Here's what we're gonna do. We're gonna simplify 4 things. Now, I think the biggest thing for most students here is actually just doing the order of operations correctly. So what I'm gonna do is I'm just gonna circle the parts that I'm gonna simplify first. The first thing I do is I simplify this, this, and this, and this. These 4 pieces. Okay? So the first one, there's really not much to do. It's just negative 6, right? Circle become 36. Now, check this out. You see that little minus in there between my 2 circles? That's going to stay there. Okay? Don't lose that. What is, now I need help here. Anybody got a calculator? 2,800? 2,880. But it's negative, isn't it? Because this 144 is negative, right? So 4 times 5 times negative 144 gives me a negative 2,880. Now I've got double negative there, which you guys know we're going to do with that in a minute, right? Let's do the bottom. What's the bottom going to be? 10.
25. 10,
Okay.
10, my bad.
So the first thing that you do is you simplify those 4 parts. The next thing you're going to do is you're going to simplify this. So we already know this is going to become what? Plus. So on your guys' phones, can you do 36 plus that, please? It is. 3,000?
Oh, 100. No, 3,000.
Are you sure it's 3,000?
I'm just gonna my
It has to go down.
Oh, you're right.
No, it would be up because this is plus.
Oh, okay. 3,000.
I don't think it's 3,000.
How is 3,000?
You're adding
2,000. She's doing it in her head.
2,960.
There we go.
Because you're adding.
Oh.
Why there's no there? Okay, thank you.
Because the 10 was part of that.
Thank you.
It's part of the top.
No,
Not
that checked me out. That's
Okay,
that's
now here's why the first problems we're doing are nice problems, because these are perfect square roots. Could someone push this, type this number and push the square root button for me on your calculator? What is it? It's 54? Okay, so that's the next thing. So let's circle this, because that's the next thing we're going to do is we're going to simplify that. So that's x equals negative 6 plus or minus 54, right? Because that's what the square root of 2,916 is.
Wait, what is
So I just used the calculator. Now here's what we're going to do. We're going to split this up at this point into 2 problems. We're going to do x is equal to negative 6 plus 54 over 10, and x equals x equals negative 6 minus 54 over 10. So we're going to do 2 branches, one for the plus, one for the minus. So let's do the top here. What is negative 6 plus 54? Just use your phones if you need to. 48. And this would be negative 60, right? I'm out of space, so I got to come back up here again. All right, let's reduce these. That's your last thing you want to do. What's 48 over 10? That's going to be, yeah, if you want to do decimals, you can. I want to stick with fractions for now, but so I know that 2 goes into both of these, so I think it's going to be 24 over 5 if you reduce it by 2. Over there, though, that one's going to be nice and clean. It just comes out to be negative 6. So there's your 2 answers. Okay? So there's a lot of steps there. But if you took good notes, you could follow it. And it's really just a bunch of multiplying, adding, and subtracting. But I want to warn you guys of a few danger zones. Okay, watch out for those double negatives. Watch out for those double negatives. Yeah. Sure. Somebody just went out though. Who was that? Who's just behind you, Kayla? You don't know their name. You're a terrible person.
Oh, Annie?
Leaders and everything. Yep, student practice. Ready?
Oh,
Okay, go.
well, you know, I gotta go.
Sean, Leslie, you guys want to sit through class today? I can't give you participation points. You guys want to sit through class, Leslie? You want to sit through class? Or you want to participate? I guess that's a participation answer. I'm not sure. Didn't get a verbal response.
Mr. Ray,
Yeah.
you can sign.
I can't. Do your math. Do your math there. Come on now.
Can you please look at the
Sure. Is there? Nice. Love that. It happens. It does happen. Very good.
Okay, so he told me that 64.
You know, I'm just about ready to start going over it.
Mr. Bailey,
Yeah.
I don't understand this step.
Okay, I'm going to go over it now, and I'll show you when we get there. Here you go.
Is there no,
Annie, what goes here? And how about here, Annie? Okay. Let's do Paris. What goes here? -8. You do want to include the sign with it. How about here, Paris? Uh-huh. And here? And here. Yeah. Okay. So we're doing these 4 parts here. Shh, quiet, please, guys. Hannah. Okay. So double negatives here, we get 8. This is 64. Bring down your minus. This was kind of a trouble for a lot of you guys here. 4 times 4 times 4. We were kind of doing weird things with that. I saw quite a few of you guys. So you just do multiplication straight across. So 4 times 4 is 16 times 4, 64.
But then it subtracts, so it's 8.
And so we end up with, at this point, the square root of 0. And what's the square root of 0?
0.
So now I've got a really common mistake that I see people make here, by the way, is after they take the square root, a lot of times they like to leave that square root on there. Like, for instance, I tell people to take the square root of 9. You know what they tell me the answer is? That's wrong. After you take the square root symbol should be gone. So just be aware not to do that, because that'll mess you up. All right, so we took the square root of 0 and we got 0. And now we get 8 plus 0 over 0 and 8 minus 0 over 0, which is, I'm sorry, 8, not 0. 8 plus 0 is 8. 8 minus 0 is 8. They both give me 1. Therefore, we really only have one answer. This thing only touches the x-axis at x equals 1. Okay? So, now this one was a nice one because you get to use your calculator and you don't have to worry about square roots. The next one I'm going to say is other than doing multiplication and stuff, the issue is the square root. You can't use your calculator for the square root from now on. But I hope that I'm not giving you ones with numbers that are so big that you have to break it down for like ever. So we're going to try to keep those numbers small. But for the next few examples, there will be no calculators on the square root part. All right, here we go. Let's do an example 2. Ready? Yep. Oops. Okay. Okay, guys, here we go. I'm just going to skip the step where I plug in 0 because it just takes time and it doesn't really help us. But technically, that's what you're doing. You are plugging in 0 for y. Thank you. All right. So, what number goes here? Whoops. 10. Yeah. How about here? 10 again. What goes here? Good. It's the number in front of the x squared. If there's no number there, we can assume it's a 1. So in this case, my a is -1. What's my c? How about here?
What's it called? 10. Wait, 1.
-1, a. All right. So we've got it plugged in. Let's simplify our 4 chunks here, right? We have this chunk, this chunk, this chunk, and this chunk. What's this become? What's this become? Bring down your minus. Don't forget that guy. Bring him down. And now we do this. What's 4 times -1? And what's -4 times -20?
Wait, whoa. Positive 80.
Positive 80. And on my bottom, what do I got? Okay, I've got my 4 chunks done. Now what do I do?
Subtract 100 minus 80.
Good. So we do that. That gives me.
Your voice too.
It is. It is tweaking today. Oh, tweaking again. Oh, tweaking again. There. Okay. Now this is where things get different, you guys. We have the square root of 20 there. Does 20 have a nice square root? No, it doesn't. There's not a nice square root of 20. So here's where things are going to get a little bit different. We're going to break down this 20. Now somewhere on the side of your paper, I want you guys to break down the 20 here with me. Ready? What does 20 break apart into?
5 and 4.
5 and 4.
And 2 and 2.
And then 4 breaks down into 2 and 2. And we have 5 with 2 2's. And when a mommy turtle and a daddy turtle love each other very much, they have a baby turtle and then they leave, right? So now I've got x equals -10 plus and minus. What am I going to replace the square root of 20 with? 2 radical 5. That's what I want you guys to really walk away from with this problem. That's the new part. The rest of it's really not all that amazing, but that was the main part I need you guys to get. We broke, instead of using our calculator to do this and getting a decimal, because you would have gotten a decimal, we break down our square root the way we learned before. So the square root of 20 became 2 square root of 5. That's the new part. Okay? Oh, cool. Okay. Now, the next thing that we want to do is this is also a little bit new, but not as big of a deal. Is I want you guys to circle these 3 numbers. And then I want you to write this on the side. Reduce. Those 3 numbers, we want to reduce them, but it has to be all 3. So if you don't have all 3 there, you can't reduce it. So if there's no number right here, you're going to skip this step. But if you have all 3, you are going to reduce. So is there anything that divides into 10, 2, and 2? 2, right? So let's do that. So if I reduce those all by 2, this becomes what? Uh-huh. And what's this become? We'll get there. What's this become? Aww. Yes, I love technology, but not as much as you see. Somebody could tell me the name of the movie. I'll give you 5 points.
See.
Yes, I love technology, but not as much as you see.
Robots.
Always and forever. It's a little old for you guys now. No?
What was the era? What do you think?
It's like Napoleon Dynamite. You ever seen Napoleon Dynamite?
Yeah.
Oh, so like
It's
the
at the very end.
Breakfast Club.
Oh, that's really old. Like I wasn't even born when Breakfast Club came out. All right. So these three here reduce.
Wait.
I'm gonna erase down here. Okay. Almost there. Now this is one little exception. If you have a negative on the bottom, we don't like negatives on the bottom. So if you ever have that, what we're going to do is we're going to switch them. So here's how it works. I'm going to change that to a positive 1, and the 5 is going to become a positive 5. We don't need to switch this sign because it's already got both anyway, right? No negatives on the bottom. So I'll put that in parentheses. Change sign on top and bottom. Change sign top and bottom. Change the sign on the top and bottom. All right, and one other little thing. When you have a fraction, do we? Now, these things don't always happen, but I'm just, in this case, I picked one that kind of has a bunch of stuff in it, like negatives on the bottom and reducing, you'd always have to reduce. But in this case, when you have a number on the bottom that's 1, do you need to write it?
No.
No. So what can I really just write here as my final answer?
X equals 5 plus.
Now you could I write these as 2 separate equations? I could, but I'm not going to. And the reason I'm not going to is because when you have a square root left like that, you can't actually combine the rational number with the irrational, so it doesn't really help us. So we just leave it like that. So this one was different. The first thing that was different was the square root. The next thing that was different was the reducing. And you might want to watch out for these other little weird things like negatives on the bottom, get rid of it. And then give a 1 on the bottom, get rid of it. All right. It was. Let me throw one at you. I don't know if it's going to have all those things. You need that back? So while a few of you guys are writing, when would you not reduce? If they don't have anything in common, when else? When you don't have all 3 numbers there. It has to have all 3 to do it. Okay? When we change the signs, we change the signs here and here if what? If there's a negative on the bottom. Okay? Are we good now? Still writing? Tell you what I'll do then. I'm gonna go ahead and erase this, and then I'm gonna write your student practice up because I don't want to lose too much more time. Here's yours. 2x squared minus 6x plus 8 equals y. All right. Now you guys are going to have the thing where you have to break down that root, take out the pairs, probably going to have to reduce, etc., etc. Okay? Hmm? Yeah, I think so. Minus a little bit. But yeah, I think we started here.
Is there a last one? Because this is like the last one I have.
Well, I do have something else I'd like to get to, but it's a matter of time. We probably won't do anything else after this. Hey, what's that? Sure. That's correct. Yes. What happened? Oh. I can do that. If I find my pen. Am I still recording? Oh, the new part. Okay. Now, at this point, do you guys remember what to do when there's a negative in there? You just take that out, and what do you put in the front? An I. After that, just break it down like you normally would. Okay? So take out an I and then break it down like you normally would. Actually, because we only have like 3 minutes remaining. But let's break down the 28. What makes 28? So what can I take out? So this I-28 becomes 2I root 7. Can I reduce?
Yes.
I have all three, and they all have something in common. What can they reduce by? Okay, do I have a negative on the bottom? So we're not going to switch the signs, and you have to keep it. Now, guys, I want you to understand what this means, though. What does this formula help us find? Roots. If you have imaginary roots, what do you think that means? It doesn't touch the x-axis. That's the end. I'll leave it up there for you for